Welcome everyone to our first external Artificial Intelligence in ARM webinar, and thank you for being here. My name is Hannah Collier, and I work at the ARM Data Center out of Oak Ridge National Lab as the metadata team lead, and I'm now part of the newly formed AI and ARM team. We're excited to talk to you all about some of the AI efforts and work going on within ARM and introduce you to the team. But before I start sharing some slides, I wanted to pass the mic over to ARM's program manager, Sally McFarland, for a few words. So Sally.
Great, thank you, Hannah. So as Hannah mentioned, my name is Sally McFarlane, and I'm the DOE Program Manager for the ARM facility. And I'm happy to welcome you all to the AI and ARM webinar today. Taking advantage of the capabilities of artificial intelligence, or AI, to advance scientific discovery is one of the priorities for the Department of Energy and the Office of Science, in which ARM sits. And within DOE, you might have heard of DOE's Genesis mission, which aims to develop an integrated scientific platform that connects DOE's supercomputing, user facilities, data sets, and scientists with AI tools and workflows to significantly increase the impact and productivity of research and innovation. So to align with and support this Genesis initiative, the ARM user facility has developed an AI implementation plan to start integrating AI more fully throughout the workflows in the facility, to develop AI-ready data sets, and to enable AI to advance scientific discovery by the research community. So ARM is hosting this webinar to inform the research community about ARM's AI implementation plan. I can't say that word. And to get your feedback on it. So as part of this plan, it's important that integration of AI be useful both to the facility and to users. We want to identify the best AI methods and tools that will help ARM staff with their work and help ARM scientific users address their research challenges. It's also important that AI be incorporated thoughtfully as the most useful tool and technique for the problem at hand. The goal isn't just to add AI for the sake of adding AI, but for AI to actually empower researchers and staff to solve their scientific and technical challenges. AI also needs to be implemented in workflows and research activities in ways that are transparent, reliable, and able to be evaluated. It's important that we're able to ensure trustworthiness in the data and tools being produced by the facility, as well as for researchers to be able to reproduce and validate each other's scientific results. So as a user facility, ARM has multiple roles in moving forward with AI. As I mentioned, integrating AI into facility activities to improve facility operations and effectiveness, developing AI-ready data and AI tools and techniques to help users maximize scientific discovery with ARM data, and working with the research community to help develop domain-specific standards and best practices for application of AI in atmospheric science. So including things I already mentioned, such as consideration of validation and trustworthiness of AI methods and models. To most effectively enable AI for scientific discovery within ARM, it's important that ARM hear from research users about their needs and scientific challenges. So the primary goal of this webinar is to begin a two-way communication between the user facility and ARM users about ARM's AI activities. So ARM staff will discuss how they're enabling AI within the facility, describe the development of some of the new AI-enabled infrastructures and data sets, and describe how ARM users can provide feedback to ARM on your research needs and capabilities needed to address them. So I want to thank you again for joining the webinar, and we welcome your engagement and feedback to help ARM develop the most effective AI-enabled datasets, tools, and activities to support your research needs. So thank you, Hannah.
Thank you, Sally. And I think we also have our technical director, Jim Mather, who's going to give some opening remarks.
Yeah, thanks, Hannah. Yeah, I just wanted to give a add on to Sally's comments with a few words about how we got where we are here today in this webinar. ARM had been developing AI capabilities for at least a decade, but that really started to pick up a couple of years ago as it has in the larger community. And then just a little over a year ago, ARM were asked by DOE to develop an AI plan that Sally mentioned. Adam Tyson led the development of that plan, and that came out internally about 6 months or so ago. It included some of the things that Sally talked about, this making sure that we developed an effective but responsible AI framework to accelerate science using ARM data to reduce staff workload and perhaps enable activities that really have not been possible, improve data usability, including discoverability of data, and provide support for ARM staff to make use of these tools. Now, since that plan, Adam wrote that plan late last summer or early in the fall, things have accelerated even more. Things are just going so fast. I'm sure you are aware, including this new Genesis project. And so it became clear that this was not something that we could just do in addition to everything else we were doing. And so this was something that Adam was taking on in addition to his other duties. Developers were doing along with their activities. And so Hannah mentioned this AI and ARM team. So just about 2 months ago, we decided that we really needed to dedicate efforts to coordinate activities across the ARM facility. And so we first looked for a coordinator, and Scott Collis is the coordinator for this team. And then Hannah, along with Karina Lansing, Shrek Shah, and Jingjing Tian make up the rest of this AI and ARM team. So they represent expertise to review activities and to help coordinate activities across the facilities. They led a webinar for ARM staff about a month ago to introduce themselves and sort of update the AI and ARM plan. And now here we are today. This is our first engagement with the broader community to really hear from you. And we'll talk to you about what we're doing and hear from you what you need. As Sally said, we really want anything we do to be of greatest use to you. So we want to hear from you what you need. And as we roll out new capabilities, we want to hear how they're working for you. So please do today and then beyond today, let's give us your feedback so we can do this most usefully to you. And thanks, Ann. I'll turn it back to you.
Awesome. Thank you. All right. That is the perfect background to get us started. So I'm going to start sharing my screen here. Share. Okay. I got the thumbs up. All right. So for today's meeting, here's our agenda. We're going to start with some introductions, including an overview, the AI and ARM team, our goals, some updates. Then we'll have a few talks about the ARM AI resources, some ongoing AI ML activities within ARM. And then, like Jim and Sally said, we want to hear from you all. So we'll have some interactive polls that you're welcomed and encouraged to join in and participate in. And then we'll have a slide with some ways you can contact us. And then we'll end it with a Q&A session. So we're hoping to have a good 20 minutes for just Q&A. So be thinking of questions or ideas that we can answer as we go through. And with that, I will pass it along to Scott Collis.
Thank you so much, Hannah. Welcome all. Thank you so much for joining us. My name is Scott Collis. I am the AI in ARM coordinator, and I lead the AI in ARM team. First thing I want to let you all know is that while modern technologies such as GPUs and the new raft of architectures we're seeing coming out from the technical sector are supercharging AI. AI in the atmospheric sciences it's not a new thing. In preparing for these webinars, we did some digging, and one of the earliest papers we can see is this one from 1988. And if you go to the next slide, 1998, if you go to the next slide, Hannah, that is me in 1998. That is me in my second year. We call it second year in Australia. You call it your sophomore year, I believe, here in the United States, doing my physics lab. This was way before joining ARM or anything like that. What has changed is the power of some of the tools that we are using and the sheer amount of data that they can take in and the impact that they're going to have on our science going forward. So if you go to the next slide, Hannah. if we look at this is our first externally facing webinar. Our role as the AI in ARM team is to shepherd AI activities across the facility. There is much more than the five of us that Jim mentioned in the beginning. We are here to coordinate the activities. We're not here to necessarily do them in as of ourselves. That's led out of our huge multi-lab collaboration that is ARM. But we have a vision and mission. And our vision is the responsible use of AI in ARM that boosts the impact of the facility and the fulfillment of the staff in the facility. And our mission is to remove barriers to AI tool uptake and to act as a facility-wide sounding board for the responsible use of AI usage and to ensure ARM remains on the forefront of AI-empowered innovation. You'll see that word responsible again and again and again, because one of our roles is to maximize the impact and minimize the harms. If you go to the next slide, Hannah. It is really useful to define at the very beginning what artificial intelligence is, because it's actually a really broad range of algorithms. Folks like me who have been working with atmospheric and other physical data for decades have used algorithms like k-means clustering, self-organizing maps, and so forth. That is absolutely AI. Not all AI is agentic AI. Not all AI are LLMs, ChatGPT, and these very large models that are basically predicting the next token in a series of things. And not all science problems we're going to deal with are particularly applicable to LLMs, even if they tend to capture most of the attention right now. So our scope is all of AI for all of ARM. So really looking at the totality of different algorithms that can unleash the amazing potential that is contained within ARM data, to really further ARM's mission, which is to improve the representation of all the components in models across scales to build a predictive understanding of our atmosphere. Next slide, please. Now is a particularly critical time for AI and ARM. There are three key things that are occurring right now, and that are linked to the Genesis mission. One, pretty much, I think it's early next week, which means that many people actually already have their proposals together in grants.gov and so forth like that, is a Genesis request for applications. Question 15A in the RFA is a specifically ASR aligned question, and 15B and C, these are all the water for energy questions within, or science focus areas within, challenge questions within Genesis, could use ARM data, as could 21A within the Genesis RFA. So once the proposals that are selected for funding have been chosen by the Office of Science, we expect for there to be an increased pressure on ARM data to be made useful for AI workflows. There has also been a recent call for regional centers that came through a Dear Colleague letter from the Office of Science. Again, throughout this Dear Colleague letter, there are very, very strong links to Genesis and strong links, again, back to ARM as the key user facility within BER. Furthermore, there was a recent call for white papers to the labs for to guide the deployment for the ARM mobile facility too. This call for white papers also encouraged and mandated strong connections to the Genesis mission in the response to this. So we are going to need to and will connect ARM data to Project Genesis. This will lead to an increase to the demand for AI tooling, for example, data proximate GPUs, and the need for AI-ready frameworks to work with ARM data has initiated efforts to explore and define its interfaces and interactions with the Genesis platform, and almost more importantly, the American Science Cloud. The American Science Cloud is going to be real, honest infrastructure that folks can develop these algorithms on, and the folks across ARM are very aware of this and are embedded within some of the American Science Cloud teams to make sure that ARM data can interact with the American Science Cloud. ARM has an archive of over 8 petabytes of data. We are the archive for high quality, well documented with rich metadata, data that is pertinent to atmospheric process level science. Part of our focus, and this is going to be a key word going forward, will be AI ready workflows. You've heard about AI ready data. Our focus is on AI ready workflows, because when you come to AI ready data, the question is always begging, AI ready for what? So workflows are really, really important here, because we don't want to just prioritize one data set. We want to really prioritize how we can really look at interacting data sets. One of the ARM's strengths is the totality of measurements we take, everything from aerosol, remote sensing, clouds, land surface interaction, and the best science is done at the interface. And this is where AI will really supercharge our efforts. Hannah, next slide, please. So this is your take-home slide. What are we going to do about it? Why did we form the AI in ARM team, and what is the AI in ARM team going to do? We've broken down our efforts into 3 broad areas: AI in operations, AI in communications, and most pertinent to this group, AI in science. We are going to set up a governance document. This sets the guardrails for the responsible use of AI in ARM. Forget the timelines then, we've blown through them. We're going to have the draft in May. May 11th, when our draft is due to ARM's management group. Most importantly, we're going to have subject matter experts really review some of the AI work we do and basically take a Hippocratic Oath point of view, first do no harm, and develop stoplight narratives for usage modalities across ARM. This will be guidance staff will need to be looking to their own institutional policies. We have convened, and you'll meet them very soon, the AI in ARM advisory group. This is a 6-member panel which will help guide the AI in ARM group. We're going to hold webinars. This is the second and our first externally facing webinar, and will be far from our last. And as Jim said, we are looking for your guidance to how we can most help your efforts at being impactful with ARM data, and that's going to guide our webinars going forward. These will be held semi-monthly, maybe once every 2 months, and one of our goals is to raise the awareness of AI activities facility-wide. And probably one of the most exciting things for me, because I have a dual role here, both in my AI and ARM team role, but also my role in workforce development, are hackathons. I'm a kinesthetic learner. I like to code. I like to get my hands dirty with data. I don't understand something until I've coded it myself. Call that a failure, call it a strength. Our goal really is to engage with you all on this. And I can't really talk much about that now. We have some exciting news coming soon, but there will be plenty of opportunities for scientists and students to engage in learning activities and really get your hands dirty with ARM data. We'll have a public AI strategy. We're taking what Jim talked about with the amazing work that Adam and the AI in ARM working group have done. We're not going to actually have to do a huge amount on that, but we need to combine some of the other plans that are in ARM to one public-facing plan. And the other idea is to have what the tech community calls an unconference, which are basically unstructured office hours. So again, on a semi-monthly basis, we plan to have basically an open office hour where you got a question on AI and ARM, drop in. We can chat. No agenda, just a chat. Come as you are. Next slide, please, Hannah. So I am super excited to introduce you to the AI in ARM advisory group. First thing you'll notice is there are 5 names on this list. We're actually going to add our 6th member because we recently discovered that there is a really similar effort to ours ongoing in NCAR. And so we're actually working with NCAR to have like kind of a joint extra member between our two groups there. And we have some of our AI in ARM advisory group joining us today. One of the team members that could not join us is Daniel Rothenberg, who had other duties today. He is the co-founder and head of data at Brightband. Several of us have had a long history of working with Daniel. He's worked with several groups, including the NSF Center for Responsible AI at OU. But I do want to give some of our members an opportunity to introduce themselves. So Meredith, if you could unmute yourself and briefly introduce yourself to our community.
Good day, everybody. Thank you so much, Scott. I hope everyone's well. My name is Meredith Goins. I'm the Executive Director of the World Data System International Program Office. I'm physically located at ORNL. WDS is around to help data repositories be awesome, as one of my scientific committee members states. It's about doing the right things with data in the right way. I'm proud to say that ARM is a member of WDS, and we appreciate that they stay a certified Core Seal repository, which means that they have been peer-reviewed and vetted by others to show their excellence. So I'm very pleased to be a part of this advisory group and happy to serve. Thank you.
Wonderful. Thank you, Meredith. Polan, are you able to unmute yourself and introduce yourself to the community?
Thank you, Scott. My name is Polan Ma. I am an earth scientist at the Pacific Northwest National Laboratory in Richland, Washington. It is an honor to serve as a member of the AI in ARM advisory group. My work is primarily on the development of Earth system modeling capabilities with a research focus on the aerosol cloud precipitation processes to support the DOE mission needs. Over the past few years, we have incorporated the AI approaches in our scientific workflow, including developing AI surrogate models for complex physics, applying explainable AI tools to identify the intrinsic connections within the complex system, using agentic AI for software development, and then integrating physics and AI to ensure trustworthiness. Many of our work are based on ARM data, and we're very excited with the great potential. The new AI in ARM initiative provides a new mechanism to accelerate scientific discovery, which is great. I look forward to work with the AI in ARM team and learning from the community. Thank you.
Thank you very much, Polan. Rashab, are you able to unmute yourself and introduce yourself to the community?
Sure. Hey, thank you. Thank you, Scott. So my name is Rashab. I am based in Atlanta. I actually come from a research background, but my work has been completely building the GenAI solutions end to end. I lead a team of 50 people at Citi. Basically, I lead like a whole portfolio for risk and control GenAI. We basically develop products which actually being used by users across 90 plus countries across the globe. And not just like GenAI solution, right? We also build like complete end-to-end product, starting from backend APIs up until like UIs. And the major challenges we see in the industry like banking is basically the scale, right? Like how many users are going to use these GenAI solutions. So that is the bigger problem than actually building some of GenAI components at a smaller POC level, or like a smaller startup level, or like a medium company level, right? So scaling these GenAI solutions is the biggest problem we actually face, and how we actually deal with it. I think that's what I learned at this job, coming from a research background. Another thing is governance, right? Like security and how you actually responsibly use AI with the finance data. I think that is something we also do a lot at Citi, and we have like different mechanism how to guardrail some of the data, especially with the restricted and confidential PII. I think those are some of the areas my team also focuses a lot on. So thank you for the opportunity. I'm glad to be part of this advisory group. Thank you.
Wonderful. And finally, Douglas, if you're able to unmute yourself and introduce yourself, that'd be much appreciated.
Thanks, Scott. Hi, everyone. I'm Doug Strauss, Senior Research Scientist for AI and Machine Learning at NC State University, also affiliated with NOAA's National Center for Environmental Information. And my background, I had my degree in stats and then moved into geography and looking at how to use machine learning specifically as a tool to improve the environmental monitoring and modeling with satellite and other sorts of data. And so with NOAA, I worked closely with NOAA colleagues and NOAA Center for Artificial Intelligence, specifically looking at AI-related data that has been mentioned briefly at the beginning of the intro to ARM, and also we're increasingly looking at how AI can be used to facilitate the research workflows by understanding the data to orchestrating research and then serving the information to the public in general. So I'm really looking forward to working with the group and support the ARM AI in ARM group.
Wonderful. Thank you, Douglas. And Hannah, if you could go to the next slide. Jim already briefly introduced our team. And again, you can see the theme here along those three key areas. We have different representatives in our group with Hannah Collier from Oak Ridge National Lab representing us in communications, Chirag Shah from Oak Ridge, and Karina Lansing from PNNL representing us in operations, and Jingjing Tian from PNNL representing us in science. We've also invited Mike and Adam to join us ex officio. Mike really bringing that communications expertise, which is super important, because if you've used generative AI, you'll know that there is, again, great opportunities and huge pitfalls in communication, and Adam, who really kicked this whole thing off. Next slide, please, Hannah. And finally, Hannah will reiterate this at the very beginning, but these are your contact mechanisms. And the message I want to leave this entire community with: AI is not coming for your job. It can't. This community, our ARM users, are so impactful with what they do with ARM data to really help improve our predictive understanding of our planet. Our mission is to empower you, to empower discovery using new tools, and the science and the meetings and the scientific interactions we have are irreplaceable. So we are here to put the guardrails on and to find the best and most impactful uses, and to take advantage of this new focus on AI within the department. Not new, sorry, reinforced focus on AI within the Department of Energy, so that really will benefit ARM and our users. So Hannah, I'll hand it back over to you.
Thanks, Scott. All right, so this is just a quick overview to demonstrate some of the AI initiatives going on in ARM. I'm not going to go through all of these, but you can see the different sections of AI work within the ARM community. These involve a lot of different people, a lot of different research areas. And we also have 34 AI ML keyword tag publications in our publications database from the past 12 months, which is up 4 from our last webinar, if you remember, if you were there. Basically, we just want to show that there's a lot going on in the AI space internally. And so to dig a little deeper into that, we wanted to have Michael Giansiracusa to present on the AI resources that we have within ARM. So Michael, if you would like to go ahead and unmute yourself and just let me know when you want me to change slides.
I will. Thank you very much, Hannah. Hello, everyone. My name is Michael Giansiracusa, as Hannah said. As Scott mentioned earlier, at the ARM Data Center, we are really getting ready for users who want to use AI for knowledge discovery using ARM data. One of the core challenges with AI and machine learning in atmospheric sciences and in many of the sciences actually is simply moving the data to the compute and vice versa. In ARM, we struggle with an issue where we have tons of data in our deep archive and tons of compute over on the Cumulus side of the hall, but it can be difficult to access at times. And so our primary goal right now is to bring the compute directly to the data and to lower the barrier of entry, giving you the tools to train models without the friction of massive data transfers or overly restrictive access controls. And so for interactive analysis and exploration, we have our open research environment at the ARM Data Center. We have Jupyter Lab pods that we've spun up in our Kubernetes cluster and configured with direct access to our data, our ARM data archive. that is on spinning disk in our data center with minimal access controls other than having an ARM account. Those notebooks and pods are available at jupyterhub.arm.gov, and you can see a screenshot of one of the interactive notebooks that we've developed during one of the interactive classes that Scott was talking about earlier. We really want to get our users involved in physically using ARM data, doing it in these interactive notebooks, doing it in places where we can collaborate and learn and grow together. And so at the bottom of the page for the jupyterhub.arm.gov, there are links for access requests and support. There's an email address there, clustersupport@arm.gov, that you're welcome to email at any time, and we are happy to help you in any way that we can. We enable Python, Julia, Octave, R, and I think Pluto notebooks in our Jupyter environment to support multi-language data processing needs, and we're happy to enable others as necessary. So please reach out to us. We're happy to help. But because pulling the data from our deep archive can still be a bottleneck sometimes, we have integrated Globus infrastructure to auto-stage data directly to your Jupyter Hub pods from our data discovery page, and we are working on other ways that we can automate deep archive access. This setup is really designed to let you spend less time managing files and more time analyzing. These pods also allow for data downloads from resources outside of the ARM data center as well. So you can get NOAA or any other data you need to do your research. Next slide, please, Hannah. So for non-interactive workloads and for scaling, we have a few paths. As I mentioned earlier, you can utilize Cumulus, which we have had for some time. It is a large cluster with several GPUs on it. It has many nodes. We use it for our most computationally intensive workflows right now, such as our Lasso dataset, which is a model that takes weeks to run. But we are really pushing heavily to bring the compute resources into our local ARM data center and in the open science area to make them easier for everyone to use. We have our own Slurm cluster, which shares access to the data archive and our staged user areas that the Jupyter notebooks have access to as well. We are working on functionality to be able to submit batch jobs directly from the Jupyter notebooks to the GPU nodes on our Slurm cluster via native Slurm commands or via Dask for distributed computing. The example you're seeing here is a Dask workflow on an HPC that has multiple nodes running at the same time, all doing collaborative computing. The outputs are then gathered back to your Jupyter environment for post-processing. Next slide, please, Hannah. So where the rubber hits the road. To empower this, we are actively trying to scale our hardware. Currently, we have 2 nodes running in our Kubernetes cluster that are running 2 LLMs. We have Llama 4 Scout and GPT-OSS model, which will be accessible via our Atlas integration framework that I'm sure some of our teams will talk about later. In the next couple of weeks, we will be bringing online a new node that is equipped with 2 A100 GPUs. We intend to put this into our Slurm cluster so that we can begin enabling proof of concept work, model development, and training. Looking a little further out, 4 to 6 weeks out, we will be receiving a new node with 4 H200 GPUs. We plan on doing a little shuffling of things around, but the long-term plan is to put 4 new nodes into our Slurm cluster that will allow us to scale, massively scale, and boost our batch data processing and model training capacity. Next slide, please, Hannah. And so for the long-term outlook and access, finally, looking toward the end of the fiscal year, we have approved funding for 2 more nodes, each with 4 H200s. We expect these to land sometime in September. As these resources come online and we begin adding them to our current infrastructure to boost our ability to offer advanced processing capabilities to y'all, we will be rolling out documentation on how to access those and notebooks and AI-ready workflows, as Scott likes to call them, to give you a crash course in how to do different kinds of AI work with ARM data. We really hope that this lowers the barrier of entry, increases the ability to do compute rather than data management, and increases our ability to enable you to do better science faster and with less issues. Thank you very much, Hannah.
Thank you, Michael. All right, so next we have Wade Darnell, who's going to go over a demonstration of a new data search feature that's being developed called the ARM Data Advisor. So I will pass it over to Wade.
Right, great. Thank you, Hannah. Can everyone hear me all right?
Yes.
Perfect. All right, so hi, my name is Wade Darnell, and I am the team lead for the user-facing tools team here at the ARM Data Center located at Oak Ridge National Lab. And today I'm going to talk a little bit about the ARM Data Advisor and how it aims to really sort of revolutionize data discovery and access of ARM data. Next slide, please. And so my team, being the user-facing tools team, we manage tools like ARM's data discovery, user registration, several other user-facing tools. And so we're always thinking about, how can we improve the user experience? How can we make data access and data discovery as intuitive as possible? And so we're really looking at how we can leverage AI to improve the user experience and make the entire process a lot more intuitive for the user. Next slide, please. And so this is our flagship application on the screen. This is data discovery. And this has really undergone a lot of usability testing. And we still actively collect feedback to make this tool as intuitive as possible for the users. And so you can see here on the screen, this is an example latent heat flux query. And so it's relatively easy to use, but you can imagine if there's a new user or maybe even an advanced user, right, and they're really needing to get to the data, you can imagine this interface might seem dense initially. In some cases, there's some things, maybe a learning curve that, the user would have to deal with. And so we really have been thinking recently, how can we really radically simplify data discovery? And so our goal with all the emerging AI technologies is to turn this type of interface that you see here, and then Hannah, if you can go into the next slide, into an interface like this, which is really reducing all of those different filters and facets into a single text box. And so this is what ADA aims to do. This is what the ARM Data Advisor aims to do. It aims to dramatically ease data discovery and access. Next slide, please. So ADA stands for ARM Data Advisor, of course, and it's sort of a nod to Ada Lovelace. And this is what it looks like. You can see the image on the left side. It's a really easy to use conversational interface, which is a single text box for asking questions and communicating with Ada. And so it's super easy to use. All you have to do is just, you talk to it, you ask it questions, and you get responses back. It's conversational in that you can just use plain language to talk with it. It's almost like you're conversing with the data. It's really awesome. And you really just sort of have to use it to really just see how impactful it is. It's really smart because it has access to, right now we're using 4 agents in the background with plans to develop and add more continuously. So it's definitely a work in progress, but even right now, it's already really smart with all the agentic architecture that we have going in the background. And it's also really portable, which means that in the future, when Ada is implemented into the different tools that we have, not only will it be able to assist users with the data discovery and access workflows, but it'll also have the context of what they're doing in the application, and it'll be able to help them use the existing applications. Next slide, please. So this is an example prompt. You can see we just asked it, what aerosol data do you have from Oklahoma? And immediately we get a list of ARM data streams with different points of information, including a data discovery link. And so what's really awesome about this is all you have to do is you click this link and you can see you immediately end up on the data discovery page. And so this means you don't have to sort through the facets. You don't have to know really what metadata terms to search for. You don't have to crawl through the metadata to find this particular data product. You don't even have to really ask it anything about the data stream or the ARM site, right? You just say, what aerosol data do you have from Oklahoma? And immediately you're pointed to this page. And so you can really imagine just how much time this saves and how much more time can be dedicated to the research instead of just searching for the data. Next slide, please. And the cool thing is Ada is able to continue the discussion. So this is from the same conversation that was on the last slide. You can follow up with something like, I'm looking for backscatter properties. Which one should I use? And you get a response. Next slide, please. You can ask more advanced queries like asking about data quality, or like we see on the page here, asking about plots for a particular data stream, and you don't even have to leave Ada to see the plots. It'll actually render them right there in the output. Next slide, please. And one thing that we've been really excited about and we're really proud of is our recent addition of ordering logic. And so you can see from some of the previous slides, we linked to data discovery. You could order the data, obviously, from data discovery. But within Ada, you don't even have to leave the interface to order the data. You can just say, I want to order. And you can see even here that data, right? Because this is from the same conversation that we've been following the whole time. This is just a screenshot from that same conversation. I want to order that data from this time period to this time period. And without even leaving the interface, you automatically get a cart rendered with the product, information about the product, delivery options, file count, and you can order it right here without even having to leave the interface. And so it's really intuitive. That was one of the main things that we were aiming for. Next slide. And so it doesn't really stop there. Ada is smart enough and powerful enough that you can send it a query like this. It may even be sort of hard to read on your screen, but this is a really huge query. I'm studying cloud aerosol properties, Southern Great Plains, what data streams and paths recommending for retrieving, and it goes on and on and on. And you can see Ada is able to handle a prompt like that. And so these two different screenshots are from the same output. There's actually more output, but it's too long to fit here because it's such a detailed query. But Ada is able to handle prompts like that. And so that kind of gives you an idea of the power and the capability. Next slide, please. And so feedback, just like with discovery, just like with any other application, that we maintain, feedback and, constant improvements are totally critical. And so you'll notice that at the bottom of every message response that Ada provides, that there's the options to give a thumbs up or a thumbs down. And so this is really important for us to be able to collect this kind of feedback. Both the positive and the negative help us, right? The negative shows us areas that need to improve. And so with the observability features, we're able to go in and see all the agentic operations in the background. And so we can see like maybe where something goes wrong. And so every little bit of feedback really helps us. And we're constantly receiving feedback and testing and constantly trying to improve the system. Next slide, please. All right. And so this is where you can actually test data yourself. You can test drive it. You can ask it anything you want. And my colleague Chirag is going to post the link in the chat for folks for convenience. But you should be able to have access to this. If for some reason you encounter an issue with access or something, feel free to reach out with us and let us know. You can find some of the contact information in one of the previous slides. But yeah, please test it out. We're actively seeking feedback. And so like I mentioned earlier, that really helps us to make Ada as good as possible. And yeah, that's all I had. Thank you very much.
Awesome. Thank you, Wade. All right. So now we have a presentation from Bobby Jackson on a new AI science product. So Bobby, just let me know when you want me to change slides.
Yeah, you can go ahead and do that now.
Okay.
Okay, so what LARS is, or it's abbreviation for LLM assisted radar scenes. I'm going to be presenting here a product that is going to be motivated by these ARM data sets providing a wealth of information that right now, if you're a stakeholder coming in or if you're just a user coming in, it can be overwhelming to see all the data that's out there. But categorizing them and storing and categorizing and labeling these data sets is actually going to help the users out a lot with finding the data set they need. But there are various issues with regarding to labeling data sets. They usually hand label, and it's labor intensive, and most of the time, there usually isn't a constrained rubric in a code book. So the labels on a data set can be highly subjective. But these hand labels are required for developing supervised learning algorithms that will be able to categorize millions of data points, such as our ARM radar data. So right now I'm working on an effort to answer 2 engineering research questions that are relevant to ARM's AI/ML efforts. So can what we call multimodal LLMs, which I'll get to in a second what these are, effectively hand label data sets for supervised learning? Then 2, once we've done that, can we operationalize an algorithm to categorize in particular weather scanning radar scenes, for example, from the CSAPR radar, the XSAPR radars, that to get using assistance from multimodal LLMs? Next slide, please. So first, I think most people here are familiar with what a large language model here. A large language model is it's a big deep learning model that could take in many types of inputs such as audio, text, images, and videos. It gives you an output. So you could be, for example, hi ChatGPT, how are you today? And it could be like, it's fine. I am fine today on this sunny April 28th afternoon. And it'll put out a response just like that. So I think most of this audience is familiar with that. But if you go to the next slide, the way these actually work is that they're not just computer programs that take in, your text and image inputs and then directly operate on those. What happens is that these texts and images are put into a tokenizer. What these tokenizers do is that they convert the text and images to vectors. And these vectors are the actual inputs to a deep learning model that is your LLM. So in the end, what you actually are doing is taking these images, converting them to vectors along with the prompt, and then the output itself is also another vector. So then the decoder has to then give you that response and in the output. And there are a couple of different ways this can go. I won't go into too much detail on this, but if you're interested in more, you could see you could look. There's plenty of resources on the internet to understand multimodal LLMs. Next slide. So examples of some of these that take in images and text are, the Claude Opus models, GPT-4 and 5. We mentioned Llama 4 Scout. That's what's available right now currently. It tested it through internal ARM users on Atlas, Claude Sonnet, as well as the Google Gemini Pro series. So also older versions of these models that are not listed here that have been available for years. I've just listed the most recent versions that are currently available. So each one of these have their own main when they perform best. So evaluate the skill of some of the popular multimodal large language models for these labeling tasks. Next slide, please. So first, we're going to explore whether this is even feasible to do. And we are going to spend the rest of quarter 3 and quarter 4 of FY26. And hopefully by the fall, we'll have a technical document for ARM describing how we, first of all, do proper labeling for weather radar scenes. So we're going to be using images from the BNF CSAPR radar for the deployment for the Bacon National Forest AMF deployment that's been ongoing. And we're going to first do with at least 2 different human labelers, test out the code book. So myself, Bhupendra, anybody else who's interested in being a labeler is welcome to contact me. And we will do is compare these labels with the code book, with the MLM, with the AI generated labels. And then we'll probably have to use some prompt engineering to prove the performance and maybe even adjustments of the code book. And deliverable in the end, we're going to have this technical document that summarizes our approach, our results, and our data methods that we used. Next slide. And if this is successful, one of the disadvantages of LLMs is that the inference time is very heavy for them. So take over an hour to label a day of ARM data, which this can get prohibitive with the amount of ARM radar data we have. So we would like to use this use this mostly as a way to generate labeled data sets for supervised learning automatically. And then we can train pre-trained vision models on these AI labeled data sets to to scale the classifier to millions of radar scans. And we have here, we got some pre-developed workflows that use deep learning and I'll go into very slightly in this lecture about what we developed at Argonne for categorizing radar and LiDAR scenes. And we have an evaluation map of the time series and confidence scores for each label that we are planning on doing, at least for the BNF site in 27, probably extend to other ARM sites as well. And we want to actually have these in the database because we want to be able to actually integrate with some of the some of the ARM data explorers, so they could be like, can you give me some radar data that was taken in a mesoscale convective system for BNF? And it will just be able to give you the answer right there. So that's going to be one good advantage of having these labels, using AI to do these labels on the ARM data to be able to make data exploration easier for our users. Next slide, please. So this is going to be based on a workflow we developed called NEFO. So back with using Argonne LDRD phones, we developed a workflow like NEFO that will attach an atmospheric plot along with a multiple choice question. And then we'll give those two as a prompt to a multimodal large language model, and then compare against an answer that against a human determined answer. So we did an evaluation of how just doing this workflow did for 144 different atmospheric data plot images. And the next slide gives you the summary of some of our results of how accurate these multimodal LLMs were. Particularly the most accurate models were the GPT models, and particularly because these are the models with the biggest number of parameters, along with the Llama 3.2 Vision 90 billion parameter model. A lot of the failure point, but there are some caveats to these results. For one, we didn't use any extra input or what we call retrieval augmented generation, where we take information from documents over the internet and documents that are in papers, and actually be able to provide a domain expertise in addition to the prompt. So right now we were just going off the raw what the model knows without any extra domain expertise input. So what we're going to do is motivated us to actually make more specific versions of this workflow. And we are going to base our LARS, which will be the next slide, which is the LLM-assisted radar scenes that combines NEFO with XRadar for pre-processing radar data, prompting multimodal large language models with radar images. So supports classifying weather radar images in arbitrary classes with descriptions given in a dictionary or now even a codebook, where we can even load the rubrics from the codebook. So it supports all open AI compatible model endpoints and Llama endpoints. It has been tested on Atlas and commercial LLMs. Next slide. So this is actually the codebook that it will pull from that we use for LARS that we can go and do. And it's just a markdown file that's in the LARS repo. And you can actually get an example of this by looking at the QR code, which will give you a link to the repo for LARS as well as this codebook. And it'll give you the overview, the data description, the image format. If you go to the next slide. And this three label classes are actually telling what the different what we have here, the isolated, what the different classes mean in terms of what to look at in the image. Now notice in here in the image that we don't actually refer to specific reflectivity values or even anything meteorological. What we have here is the image. Well, here's the image here we just have in terms of the colors that are in there. And with the labeling, and then we have a labeling procedure that the user uses in annotated guidelines. Next slide. So in the end, LARS will have a similar one where we have a plot. So this is an example of a stratiform rain scene from BNF here with the CNSC Sepher 2 at 0.5 degree tilt from PPI. And the question, we have a given criteria in the codebook. How would you classify this image? Please provide the image classification. So this would be stratiform rain for this example. Next slide. So we're going to do assessment for, we're going to assess the quality of our labels by using what's called a Cohen's kappa metric. And essentially it's essentially what it is a measure of whether the labels were put about by random. So what you would do is you would do the observed labels with the you compare the observed labels with the ones that were put out from the AI. So you have your hand labels and your AI labels, and the observed agreement ratio. Basically, you looked at the ratio of how many of them agree versus how they would agree if it was just randomly generated. And values near 0 would mean no skill, and values close to 1 would mean perfect skill in labeling. So I have some preview of some of what we've found so far in the next slide. So in particular here for phase 1, and some of the stuff is not showing, but usually what should be showing up there is we should be getting at least 0.4 to 0.6 for moderate agreement, and above 0.6 for substantial and almost perfect agreement. And we get values close to 0 for no agreement. And so we probably and you had a skillful model to have at least substantial agreement before we move on with being able to deploy LARs at scale. Next slide. So based on our codebook evaluation, right now I've evaluated 1,208 images, just taking the half-degree reflectivity from the PPI scan for the CSAPR2 at 256 by 256 resolution, comparing on the left the proprietary GPT-5-4 model, and on the right the Llama 4 Scout. And the results, they're not too different in terms of what we see here, the confusion matrices that show what the labels are, the predicted by the AI on the bottom, and what were done by the hand labeler on the top. The biggest pain point seems to be the distinguishing between the mesoscale convective system and stratiform precipitation. They do really good at labeling no precipitation time periods, and the skill is a little better with the in detecting isolated convection with GPT-5-4 versus the Llama 4 Scout on Atlas. But in general, the results aren't too different between the two models. But if you just go next, yeah. Give we high resolution or additional inputs improve this? I think we may also need to maybe fine tune the codebook a little bit. But so far, even just this half-baked example that's been put up for this presentation seems to be doing decently so far. So next slide. And this is at 512 by 512. Improving the resolution does improve your agreement a little bit with kappa scores of 0.58 for the GPT-5, and on the right, 0.53 for the Llama 4 Scout model on Atlas, indicating that indicating that the low resolution of the image is complicating the identification to a small extent. Next slide. Now after this phase 2, once we're done with the labels, we apply a workflow previously used in a 2023 paper in JTech, put up by our team. We can co-authored by myself, to identify Doppler LiDAR images using hand-labeled data. So we'll apply a similar workflow to the radar data to develop an operational model that will be used to categorize to get the confidence scores and radar data and radar images in the data. So that's currently our plans here with the LARS product. And if you like to take any questions or on any of these things, I'll be here till 2:30.
Awesome. Thank you, Bobby. I'm debating if we should, is there anyone that has a question for Bobby right now in the chat, Michelle?
No, I don't see any
Okay.
questions.
Perfect. Then I will go ahead and start with the polls. And then if you guys have questions, please feel free to share them after we get done with the polls. So this section, now that you've heard a lot from us, we want to hear from you. So I am going to stop sharing this screen and switch over to another one. Okay. Share. Okay. More about you as a group, what your needs are, and how we can help. So we have a few poll questions. Hopefully you're seeing a QR code here. Michelle is going to put the URL in the chat along with the room code, so you can enter our chat room. and you can respond to the questions as they come up on the screen, and feel free to write as many as you want. And I'll give you just a minute to get in there. And the cool thing about this is it allows us to generate a summary of your responses right after they're captured, so we can get a general idea of all of your responses in real time. All right, so I'm gonna exit out of that. And hopefully you're seeing this question in the chat room. And the first question is just, how are you feeling about AI? And we know there's a lot going on and it's exciting and maybe overwhelming. So please just let us know what your thoughts are here. I need that. I'm seeing your responses. I'm not sure why they're not showing up on here.
The question isn't coming up in questions, so it's just in
Oh, it's
chat,
not.
I think, might be why.
Oh, okay. Let me. Hmm. Oh, okay. I think it's working now. Are you seeing the question? Awesome. And with this word cloud, if you're writing a long response, don't worry. We can see all of your responses afterwards. If they're longer, they don't show up great on here. Awesome. I'm going to give you all just a minute to respond, but thank you for the participation. Yeah. Yeah, this is great. We're getting all of the range of emotions, which is very fair. So let me just let's see if we can see the summary. Can keep responding. Yeah. So we're seeing lots of mixed feelings. Ethical and environmental challenges, great point, opportunities and benefits, reactions, a lot of overwhelm and shock, cautious optimism. Yep. This is great. All right, I'm going to go ahead and switch over to the next question. Okay. Hopefully you're seeing question number 2. The second question is, what would you like help with regarding AI? And this could be tools, training, anything you think that is missing, not easily available that would help you with the adoption of AI. Yep. Perfect. This is great. This helps us so much to kind of help
Training
tune what
loud and
directions.
clear. Definitely need.
Yes. Tutorials, training, how-tos. Yep. Perfect. All right, I'm going to go ahead and take a glance at our summary here, our AI summary. Yeah, focus on tutorials, workshops, trainings, practical tools, notebooks and data sets, guidelines and best practices, support, accessibilities, especially for students. That's a great point. Foundational and applied learning. Yeah. That's wonderful. Thank you, guys. All right, I've got a couple more. I'm going to go ahead and switch to the next question. Okay, so this next question is related to kind of a known issue with AI and just in general. The data are in so many different places, and we want to ensure ease of accessing data from different sources to use specifically in AI projects, but anywhere else. So we want to know, outside of ARM, where do you find data? Where do you submit data to? Are there certain repositories or sites that you use, organizations that you go to? So yeah, we just want to make sure that ARM data can be used easily with other data as well. Perfect. This is great. We're always striving for interoperability, especially when we're thinking about the American Science Cloud and how we can prepare for that. So this is great. Thank you, guys. Okay. And if I'm switching too fast and you have some comments, feel free to email us. So we don't want to miss any comments here. This is great. Okay. I'm going to go ahead and switch to the next slide. Okay. So our last question here, we're curious, are you using AI currently? You can say no, that's okay. And if you are, how are you using it? Some examples can be, is it helping you write, to summarize meetings, take notes, for data creation, finding data to help code? If you have a specific tool that you're using, ChatGPT, Copilot, if you're using like a specific Python package, to analyze data, please let us know. And we will definitely get all of this information together so that we can know what we can help you with and what tools we need to make sure are available. Great. This is perfect. Thank you. And I definitely see a lot of Codex, a lot of Claude. Yep. Ada. Okay. All right. Well, I guess there's really no reason to turn this off. So I'm going to let it go, but I think we are good to open it up for questions and answers now. So if anyone has any questions while you're filling in some of these answers, please feel free to raise your hand or put something in the chat.
Don't be shy. Now is your opportunity to ask some questions. Particularly, I know a lot of people are really excited about ADA. So we've got Michael and Chirag and Wade and the team here.
There's a good question about what type of statistics and user data it is capturing. But one thing I do want to mention, and I'm sure Wade can elaborate on this more, is that many of these AI tools are just pass-throughs to cloud models where your data may not be as safe. All of our models are running locally on ARM hardware. None of it is a pass-through to anything else. And so we take very good care to keep all of the data safe and follow all the proper procedures for safeguarding PII and other types of sensitive research data. So that is just something to note when using Ada, is that it is all local and as safe as it can possibly be.
That's right, Michael. Thank you. On the question on what type of user statistics are you collecting or capturing with Ada, we do quite a few with the user prompts, as well as like how much time it took to execute, and a summary of what the result was. So all those things actually helps us debug and then improve the quality of the response back.
I think that's another question for you, Aidan Geary.
Yep. Okay, so the performance benefit of running local LLMs compared to more public LLMs. Chirag?
Again. So the benefits of running local LLMs is, one, first you get security, right? Your data, it's not going on a public platform. Two, we have a centralized governance thing that is coming shortly. So we are, with that, we are able to track things like, sensitive PII, something that we are not supposed to share on public LLMs. It's not going to go on public, right? We're going to maintain that. We're going to mask those things, and we're going to try to protect every bit of sensitivity that we have with our data just by running local LLMs. And another thing that we do get with local LLMs is that we can try to track things. We can try to audit, we can try to track, and we can see our own performance here. So sometimes public LLMs, they have a good way of selling their models. They give you free tokens and everything. With local LLMs, we don't have to worry about that. So if you do have experiments that needs attempts of trials, you need iterations you want to do. So basically anything that involves testing, it's not paid. So you can do that. That's another thing. So that's the other advantage that you get running things locally.
Mm-hmm.
And Chirag, if I can add to that, you need to put the definition of the acronym in there, because I can never remember. These RAG pipelines that they're building as part of Atlas, what that means is they take Llama and ChatGPT, and they can then reinforce the training on those models. So those models, in the end, they're aware of ARM data and ARM metadata in the end. So you're not just interacting with ChatGPT and Llama, you're actually interacting with, ChatGPT and Llama that's been put through ARM University in the end. And with the efforts of the team here, that's only going to get better. And with your feedback as well. So you could jump on chatgpt.com and ask it about ARM data, and it will use all the public facing information that's managed straight from our website. It doesn't have access to the ARM archive. It is not going to put in those queries there. So this is the one thing. And again, I want to share with you, I'm going to be a little bit vulnerable for a second. I am learning new things every day here. And when I sat down with Chirag and Michael G and the team and learned about these RAG pipelines, it was a new acronym to me. It was like a light bulb moment of exactly why Atlas and the system they're setting up is going to be so impactful.
That is a very, very important, advantage. All right. So when you search in the Ada or any agentic, AI within the ARM, it actually goes and fetches information from our database real time. So you get the latest and greatest, and also very specific to the ARM. Yeah.
Awesome source. I think everybody's kind of AI out and exhausted. It must be the deadline for all the Genesis proposals this week. One thing I do want to say is that this is a new activity in ARM, and as Hannah and everyone has said, we are really actively seeking feedback on how we can be most impactful. Definitely hearing about, and we've heard this through other activities that we've run over the years, the need for continuous workforce development, and not just workforce development for students, but workforce development for active scientists who want to tool up as well. And we are planning hackathons. These will come probably in and around the more like June and July timeframe for this externally facing group. Expect to see some really cool results out of the ARM Summer School as well, where we have a specific challenge for students to interact with AI and ARM data. But we are looking at, and this is again still in design, probably a wintertime hackathon that really will be focused on ARM users, and we'll be engaging with you guys on getting ideas for that. What we're really interested in as well is things we're missing. So if you listen to this webinar today and you're like, Hannah, Scott, you guys, you missed this thing, that's what we want to hear from you, because we have our own blind spots and we're really, really interested to hear feedback.
Yeah,
Andy?
and I just wanted to say we have our email up on the screen, so please do email us. You'll get a copy of the slides in this presentation. And Michelle put a survey in the chat there, so please do give us your feedback. And we really appreciate you being here, and we appreciate all of the speakers. And thanks for participating.
Thank you.
Mhm.
And thank you for testing the ADA. We saw at one point about 50 users try. And it held our GPUs, the load was only like 60 or so percentage. Yeah. Thank you for testing.
Awesome. Thank you, team. We'll see you at the next webinar.